Hi friends, welcome to My Home, My Design. So I am N. Srinivas, a professional civil engineer. Like to introduce myself and my credentials are I have 27 years of vast experience in the field of construction, backing with engineering degree from recognized university and completed PMC. I am a member of Institute of Engineers and a registered engineer in BBMP. I worked with many reputed builders, contractors and MNCs and ran my own construction company. I started my career from site engineer and gradually rose to the position of general manager, quality head, construction manager and managing partner in the said company. I have expertise in various kinds of constructions including residential, commercial, industrial and is well versed with ISO standards for quality, environmental and OSHAs. I have done construction audits, observations, supervision, checking and improvements for many reputed companies, manufacturing units, contractors, builders, developers, and for all types of construction materials. I do training and development for engineers in the field as well as institutions. Since having so many years of experience in the construction field, I literally knew the problems in the construction field. Practical problems, material, labor arrangements, labor problem, wastages, challenges, risk. I wanted to summarize these activities of building constructions in categories wise and publish it in my website called My Home, My Design. I have indicated all these problems, all these items, the methods of checking and everything is systematically explained in My Home, My Design. See now, here I want to give the importance for the quality in construction. How to do the quality construction, solution for the materials and selection of the material, doing work as per civil engineering standards and specifications. What is the professional way and why do we need professional services in building construction? All these problems will arise, right? Necessary tips, caution, advice and suggestions. I keep on giving all these in these articles. Now, for further step ahead, a thought came into my mind that I should not limit this by merely in article digital format. Rather than the same thing can be brought out in video format with more inputs which would actually benefit for all viewers. Yes, of course, this is the first experiment I am going to do. This is the beginning of my thought, the first episode of construction activities by My Home, My Design called Earthwork Excavation, including safety measures. So we will start our session now. Earthwork excavation including safety measures. Under this topic, we are going to cover all these categories. What is the scope, reference, tools required for marking and excavation, marking and setting out process, centerline markings, closing error, TBM, dewatering pumps, earth benching, safety measures, blasting, precautions, and then checklist. Now we'll explain in detail. Earthwork excavation. One of the activities shall be implemented or started. First is earthwork. Here we discuss the procedure of earthwork in steps. How actually it is carried out in the field without compromising engineering standards and specifications. We will discuss in detail the practical difficulties, solutions, precautions, safety measures, challenging tasks undergoing in all types of earthwork, including slushy soils, step by step. Scope. What is the scope? This method statement describes a proper work procedure shall be carried out during the excavation stage as per specification and contract drawings. Reference, we need to go for the good for construction drawings always. General specifications. Excavation and earthwork should always be as per specifications and site conditions. Materials in natural and all types of soils. Tools required for the marking team. leveling staff, ranging rods, steel measuring tape, 30 meters and 50 meters, plumb bobs, leveling instrument, trowels, nails, steel rods, spirit level, linen tape 30 meters, of course, paint and brushes. And similarly, some tools required for the earthwork team also. Those tools are again measurement tape, plumb bobs, crowbar, picoxy, spade, trowels, nylon threads, right angles and pans. Work procedure. How to do the excavation work as per engineering standards. Marking and setting out process. The basic idea of marking and setting out process is to prepare an accurate surface or base for the upcoming construction activities. Is it not? It is very important to tune our mind that even to start with the first activity, the earthwork itself, one has to maintain 100% accuracy in this work. Because at earthwork stage itself, if we can maintain the quality by giving 100% accuracy standards, then imagine the things, whatever it is coming up over the earthwork, which is all going to be 100% accurate. So that is why we are not supposed to compromise on the earthwork stage itself. See, the other errors, potential instrumental errors occurred due to the usage of instruments, and to ease out such errors by certain techniques. We will see those techniques. Degree of accuracy. The degree of accuracy required will depend on the type of the earthwork handling at a project site. Its precision can be measured by this, whether it is 5 mm for prefabricated buildings or 200 mm depth is required where more depth of excavation is involved. I tell you here one point, even prefabricated structure, 5 mm plays very important role, because the precision is that much accuracy is required. 1 mm, 2 mm, up to 5 mm, we have to give utmost importance. Whereas imagine if the depth of the excavation is more than 15 meters and all, there the marginal cushion is required even 200 mm. That means 8 inches. That is the degree of accuracy we can expect. So like that, we need to identify what type of the structure earthwork is going on. So depending upon the type of the structure, degree of accuracy depends. Next, coming to the centerline markings, we remember in our engineering course, particularly in surveying subject, for measuring any activity or item, we should start from work from the whole to the part and repeatedly check the correctness of one's own work with that of others, and that is based on the available information. Here, what is this work from whole to the part? Suppose imagine if a building measure 400 feet. So that 400 feet, starting from 0 to 400 feet, if we can measure the whole length, the length has to be structured by means of tape. The tape should having a sufficient length of 400 feet. So, and with regular intervals of let us say 15 feet, 30 feet or 50 feet like that. So that means if we keep on taking the reading, suppose we are holding the tape at 0 and 50, that is the one interval, 50 feet, next 100 feet, 150 feet, 200 feet, 250 feet, like that. Up to 400 feet, we can able to measure, and regular intervals of 50 feet, we can able to mark. See, this is the correct procedure, work from the whole to the part. That means 0 to 400 feet we are measuring. On the other hand, if you are not measuring like that, if you can measure part by part, that means 50 feet, and we are having only 100 feet tape. That means we need to take this 400 feet measurement in 4 to 5 steps. That means 100 feet. We need to keep on changing our tape measurements. That time, this is not going to be work from whole to the part. It is rather, it is going from part to the whole. So there the error is, accumulation of errors will be more. So that should not be there. That means work from whole to the part is always important. This is easy and simple. With the adjustment of ranging rods, pegs can be fixed. Even though the total station will give accurate results, cross checks to be done at each and every stage of earthwork. In absence of total station, by means of trying line threads, which should be passing through center line markings or grid pillars along both x-axis and y-axis, required measurements on the plan can be easily transferred to the ground. Nowadays, you people know that total station is absolutely required for all big projects and all. We can able to easily transfer x coordinates and y coordinates. Suppose if total station is not there, then this grid pillar marking helps a lot. Now, Always establish permanent benchmarks outside the working area at the initial stage itself, and levels to be carried out with respect to the benchmarks only. If this is not carried out, the errors will be accumulated and result in valuable time loss and cost of work also. So that is the reason always the benchmark should be located outside our markings. The drawings what we received from the concerned architect or consultant is exactly matching with field conditions or not. Hence, necessary checks to be done with reference to existing and proposed roads or buildings and existing permanent features. Then come to the conclusion that at what extent the plan matches to the ground conditions. So that we need to identify in the beginning itself. Suppose if the drawing measurements is not tallying with the actual in the field, then that whatever the extent, how much extent this is matching, whether it is 90% matching or 95% matching, why the 5% is not matching, then that should be brought to the notice of architect. Then if we can notice all those things before starting the earthwork itself, we can able to minimize the problems in near future. Now, ensure that the site personnel including supervisors or site engineer understand the significance and importance of all centerline markings with respect to the pegs or grid pillars. So that we need to identify. Next, finally, the completion of traverse in any direction. Say, suppose we started the traverse in clockwise direction and coming back to the point of origin with corresponding opposite direction, say anti-clockwise, is the correct method to check the work. The difference between these two readings is called the closing error, and that closing error obtained is within permissible limits, let us say 5 mm, maximum 5 mm. Then the method of traverse carried out is correct. So this is the each and every stage we have a cross checks, we can able to justify that how much the closing error is there. If it is 1 mm, 2 mm, 3 mm or up to 5 mm, it is okay. Then our excavation marking, everything is correct. Now coming to the excavation for basement and footing. For starting excavation works for any structure, we need some reference points to proceed. Hence, the first and foremost thing is to establish temporary benchmarks all around the project site. These temporary benchmarks are permanent in nature and should be clearly visible. Once these points are established, then by using paint and brush, mark reduced levels on its surface. That means our reduced level markings are ready. So with the help of these, we can able to proceed further works. For maintaining accuracy in excavation works, it is important to take grid levels at 5 meter regular intervals before going for mass excavation. But earth having sloping terrain or rolling terrain, then it is very much necessary to take grid levels at closer intervals, say 3 meters for greater accuracy. It is highly advisable to go for excavation works always in a phased manner to avoid any practical difficulties of excavation that may likely occur near the future. See, here the point is very important. We need to take the excavation in a phased manner. Suppose we have a length of, let us say, 500 feet or 600 feet. So it is not advisable to excavate all 600 feet length at a stretch. And we could not able to complete even if the 20% or 30%, they are inviting the problems for the remaining area also. Rather than that, if you can concentrate percentage ways, let us say 20% work completion, 40%, 60%, then wherever the portion of the excavation, that portion you complete it and then further go for the next stage of earthwork. In that way, we can able to minimize the practical problems. Now, collect as much as possible all data regarding water table, a period of monsoon, the density of rainfall in a particular location, and keep dewatering pumps available and a discharge point accessible. Keep these pumps ready when once the depth of excavation crosses the existing water level. So then with the help of these dewatering pipes, so we can able to remove the water whatever is stored in earthing pits and foundation pits. It is necessary to provide shore slopes or step cut the sides, sometimes called earth benching. As we excavate below 1.2 meters to ensure the stability of sides, whenever the depth of excavation is beyond 1.2 meters, that means 4 feet, barricading all around the excavated area at a distance of 1 meter from the edge of the excavation, safety measures to be strictly followed. So by doing this 1 meter away from the excavation edge and below 1.2 meter, if you can keep 1 meter benching, then the problem of sliding, falling of earth into the ground, it can be minimized. Since the cost of higher charges of machinery and equipment used for excavation is very high, planning is very much essential, and a combination of manual and mechanical means of excavation should be matched in order to avoid unnecessary idling of equipment. So that we need to plan in the beginning itself. So whether the earthwork equipment is required for the next day or not, whether manual earthwork is sufficient at that point of time, see, this project manager has to take a call on this. And now it is better to avoid excavation during night times. You all know, because while we doing the night work excavation, it is inviting trouble. Due to lack of visibility, error may occur even under artificial lights. From a safety point of view also, it is unsafe for workers and supervisors under poor lighting conditions. So please avoid as far as possible the earthwork during night times. And next, with reference to these temporary benchmarks located around the site, depth of excavation is always carefully monitored with a dumpy level, and it should be as per the required depth only. Always, it is necessary to plan excavation works well in advance for balance cutting and filling. Why? Because the excavated earth can be stocked in the site itself and later can be used for backfilling, thus minimizing cost of transportation and time. When once the required depth of excavation is reached, perhaps the hard strata are visible, then we should call structural consultant. So he should come and inspect the site and certify the strata and the depth of excavation. Immediately after the inspection, the bottom level of excavation is sealed with blending, means a layer of sand filled the gaps in the excavated surface as one of crushed and compacted stone. That means at this stage we reached the bottom portion of hard surface. There we can start our regular activities of footing, concreting or PCC. With the help of compressed air jack hammer, chiseling, wedging, etc., hard rock can be removed from the excavated area. Likewise, try to avoid blasting as much as possible. Under unavoidable circumstances, suppose if blasting is essential, if it is required, then work should be entrusted to experienced and authorized blasting contractor. After obtaining necessary statutory clearances, then controlled blasting should be resorted to. Enough safety signage, deployment of safety supervisor with constant monitoring is absolutely required during blasting operations. Caution: carefully ascertain the location of all permanent mine services, namely water supply lines, underground cable lines, sewer lines, telephone cables, optical fiber cables, etc. It is very much necessary to protect these lines throughout the phase of excavation, backfilling and compaction. Why? Because if there is a damage occurs, we cannot able to rectify all these things. So that is the reason, and we can point out by means of putting some labels over the telephone line, cable lines, underground cable lines. Wherever these cable lines are there, we can clearly identify, putting one peg stating the cable names and all. Here what I can explain with this photo is sometimes the challenging task. See, we are inviting the trouble here. Even though it has reached 7 meters below natural ground level, so here the necessary earth benching is not done. So that means they are inviting the trouble here. So in one flash of rain, so this is the problem here occurred. So in order to avoid these kind of problems, so it is absolutely necessary we can go for the benching. The benching is very much required here.